The previous lecture we discussed about how to predict the acid strength based on a qualitative approach where we don't use the pKa values, and in that the first factor which we discussed was electronegativity of the conjugate base. So basically what we concluded that the more stable the conjugate base of an acid is, the more is the acidic strength of that acid. That is, if the base which is generated by the loss of a proton is stable, then that reaction would be much more fissile as compared to if the conjugate base is less stable. And to predict the stability of the conjugate base, which is highlighted in blue, we discussed one of the factors, which is electronegativity, with 2 or 3 examples. In this video, we are going to use resonance to predict the stability or compare the stability of 2 or more conjugate bases generated from different acids. So resonance. So for this, to understand this, that how resonance can help us in predicting the stability of a conjugate base, let's take the example. So if I take the example of, say, ethanol, which is an alcohol, okay, and make it react with a base, okay, B negative. So this B negative will take up the most loosely bound proton, which is the one connected to oxygen, pushing the electrons onto oxygen, and what you get is an anion having a negative charge on oxygen plus BH. So this is the conjugate base of acid ethanol. So this is ethanol, and which is acting as an acid in this reaction, and this is its conjugate base. Okay, now if I compare this with that of ethanoic acid, which is acetic acid, common name is acetic acid, IUPAC name is ethanoic acid, and if I add base to this base is going to take the most loosely bound proton, pushing the electrons onto oxygen, and thereby generating conjugate base and BH. Now if I compare, so I'm highlighting the other conjugate base for the second reaction in green, for the first one it is in blue. So this is the conjugate base for ethanoic acid. Now we have to compare the stability of green with the blue one. Now if you look in both the cases, if you consider the electronegativity factor, then in both the cases the negative charge is present on oxygen, which is an electronegative atom and can accommodate the negative charge. But based on that, we will not be able to decide which of them is more stable. There is another factor, which is the resonance factor. So if we look at this green one, which is the carboxylate anion, the negative charge on the carboxylate anion is resonance stabilized, CH3, CO negative, double bond. So these are the two resonating structures for the carboxylate anion. And because of this resonance, the negative charge is delocalized onto 2 oxygens. Okay, so because of resonance, they get the negative charge gets the chance to get delocalized onto 2 oxygens, and greater the delocalization or spread of the charge. By delocalization, how the negative charge is spread, greater the delocalization of a charge, the more is the stability. That is from electrostatics. The more the charge is dispersed, the more is the stability of that species. Greater the delocalization of charge implies greater stability. Okay, which means green anion, which is the conjugate base of ethanoic acid, is more stable as compared to the blue one, which is the conjugate base of alcohol, that is ethanol. That is why carboxylic acids are thousands of times more acidic as compared to alcohol. So if I give them some names, say I give this equilibrium number 1, this is equilibrium number 2. So equilibrium 2 would be more towards the right hand side as compared to equilibrium 1. Let's replace this with an equilibrium. So this equilibrium is more towards the right hand side as compared to this equilibrium, which would be less towards the right hand side. So which means that ethanoic acid is more acidic than ethanol. So this is how resonance play. So we can just take the example of suppose in a molecule, suppose there is a molecule or R is any group, R, CH2, NH, CH2, C double bond O and OH. So in this case, which of the protons would be abstracted by a base? So that question can be asked. So that can easily be predicted. So you can use both the possibilities, that in one case this proton is abstracted, in the other case this proton is abstracted. So when blue proton would be abstracted, the negative charge would be on nitrogen. When green would be abstracted, it would be on oxygen, and oxygen being more electronegative can better accommodate the negative charge. So here electronegativity is the main factor. Fine. On the top of that, that negative charge would be more delocalized in the case of the green one. It would be delocalized onto 2 oxygens, while here there is no delocalization of the charge. Fine. This was based on electronegativity. Now let's take one more example. Let's try to okay, suppose I have a molecule CH3, NH, CH2 and C double bond O, NH2. Okay, so this is amide functional group and this is amine, secondary amine. Okay, so there are 2 of them. Fine. So now the question is, which of these protons would be abstracted? Would this proton be abstracted or would this proton be abstracted? Because if I go by both the ways, say I go by both the ways, okay, let's draw the conjugate base of them. So in this case, it would be CH3, N negative, CH2, C double bond O and NH, CH3, NH, CH2, C double bond O and NH with the negative charge. Okay. Now if you look at both the species, both of them have negative charge on nitrogen. So based on electronegativity, we cannot compare which out of them is which out of them would be more feasible or more spontaneous reaction. So this can be predicted based on, again, resonance factor. In this case, which is in the green, this species, if I just highlight this with the green species is capable of showing resonance, while this one, which is in coming from the blue one, cannot. So I'm rewriting this species to show you how this shows resonance. NH, CH2, C double bond O, N and H, negative charge. So this is capable of showing resonance, and because of resonance there is a better delocalization, and because of this delocalization, negative charge is appearing on oxygen, which is more electronegative even than nitrogen. So this contributes to the stability. So if you add base to this reactant, then this proton, which is connected to the nitrogen, that is connected to the C double bond O, that is preferably abstracted as compared to the other one. I hope this clears the concept of resonance in predicting the acidic strength of an acid. Thank you.